In this video, I will try to explain the meaning of electric dipole and dipole moment. So as the name indicates, it is electric. Okay. So dipole can be in magnetic field as well. But here we are talking about electric dipole. And there are a lot of similarities between electric dipole and magnetic dipole. So if you understand electric dipole very well, it will be very easy to understand the magnetic dipole as well. So this is the electric dipole. Now let us try to understand what is this dipole meaning. Di means two, okay, and pole means poles. So there are two poles, that's why it is called as dipole. To understand the electric dipole, I have got two examples over here. So this is the example one on the left hand side, and this is example number two. So in the example one, what I have done is that I have taken two charges. First one is 6 coulomb charge, and second one is 2 coulomb charge. 6 coulomb charge is a positive one, okay, this is the positive charge, and the 2 coulomb charge is negative one. So if you want to draw the electric lines of force, this is how you're going to draw it, from the positive to negative, like this. So first two lines will be absorbed by this 2 coulomb charge, but since 6 coulomb charge is more powerful, there will be more lines of forces, like this, and they are not getting absorbed, like this. Okay, only first two lines are getting absorbed, this one and this one. Now consider the second example. Here we have got these charges with the 2 coulomb each, and both are positive and negative. Okay, first one is positive, second one is negative. So if you want to draw the lines of force in this case, what will happen is you can draw it this way. So you can see that in the electric dipole, what is happening is that all the lines of forces, electric lines of forces that are originating at the positive charge, are getting absorbed or sucked in by the negative charge. So there are no lines of forces that are getting outside. Okay, and that's why it is called as electric dipole. Both the charges are equal, 2 coulomb 2 coulomb. That is the first condition. And other condition is that first charge should be positive and another charge should be negative. Then it is called as electric dipole. Now let us try to understand what is electric dipole moment. So in the electric dipole moment, what happens is that it is just a simple calculation, dipole moment, which is given by this formula. Charge. So you can see that Q1 and Q2, these two charges of same magnitude, even if they have different type of charge, that is positive and negative, they have got same magnitude, 2 coulomb. So we take that charge, let's say Q, and then multiply this with distance between these two charges. So let us say D, and that is called as electric dipole moment. Charge into distance between these two charges, equal charges. And same concept you can apply on the magnetic field as well. There will be magnetic dipole, and instead of charge, there will be a pole strength. That's it. That is the only difference. Pole strength into distance between the two poles. That will be magnetic dipole moment, or we simply call it magnetic moment. Thanks for watching.